Good evening, everyone, and welcome to the Q&A session 48 from the playlist of IIT-JEE Main Physics. The topic is the helical motion of a charged particle under the influence of a magnetic field. So, based on this topic, I have one question for this session, which is written here on this board. So, the question here is: electrons from the electron gun are accelerated through a potential difference V0. So this is the electron gun, and the electrons are emitting from here, from this electron gun, through a potential difference of V0 as shown in this figure. The electrons emerge from a narrow hole. So this is a narrow hole. So the electrons are emerging out from this narrow hole into this magnetic field region, which is parallel to the x-axis, and the intensity of the magnetic field is equal to B. So the paraxial electrons will be refocused on the x-axis at a distance. So there are four options here, and we have to find the correct option. Now the first thing which we have to know is what are the paraxial electrons. Now the paraxial electrons in this case are those electrons which are moving very close to the x-axis. And the paraxial electrons will be refocused on the x-axis when they complete a distance equal to the pitch. Now what is pitch? Pitch is equal to the velocity of the electron in the x direction, say it is Vx, multiplied by the time period. What is time period? That is the time taken by the paraxial electrons to complete this linear distance in one complete revolution. So here we have to find the value of Vx. Now here the electrons are accelerated to a potential difference of V0 from this electron gun. So by using the work energy theorem, which states that the change in the kinetic energy is equal to work done. So here the initial kinetic energy of the electron is 0. So the change in the kinetic energy will be equal to half m Vx square. And the work done is equal to Q into V. So Q is the charge on the particle. So here the particle is an electron. So that's the work done will be equal to E into V. So from here, the velocity of the electron along the x-axis will be equal to 2. Now here V is what? It is the potential difference across, or you can say the potential difference through which this electron is accelerated. So here it is V0. So the velocity of the electron along the x-axis will be equal to 2eV0 divided by m. So I am writing this velocity here. Vx is equal to under root 2eV0 divided by m. Now here the paraxial electrons will be following a helical path. Helical path, that is, it will be a spiral motion. If the angle between the direction of the magnetic field and that of the direction of motion of the charged particle is less than this 90 degree, or you can say when the theta is not equal to 90 degree. So in that case, when the theta is less than 90 degree, then in that case the charged particle will follow a helical path. So here the paraxial electrons will follow a helical path, and they will get refocused on the x-axis after traveling a distance equal to the pitch. Now pitch is what? This is equal to the velocity of the electron in the x direction multiplied by the time period. So Vx is already calculated, which is equal to under root 2 eV0 by m, and t is the time period. So Vx is equal to root 2e V0 upon m multiplied by time period. Now time period, I will be using the standard formula for the time period of the charged particle which is executing a helical motion in a magnetic field region. This is equal to 2 pi m divided by qb. Now q is what? The charge on the particle, which is equal to E in this case, and b is the intensity of the magnetic field. And here m is the mass of the electron. So here m is the mass of the electron, E is the charge on the electron, b is the intensity of the magnetic field, and v naught is the potential difference through which the electrons are accelerated. So from here, P is equal to if I take this value can be further written as under root 2 EV naught divided by m multiplied by, if I take this in under root, then it will be equal to 4 pi square m square divided by e square b square. I have taken this value in under root. So this E and E will get cancelled out. So finally I will be getting the value of pitch as 8 V naught pi square m square divided by, sorry, m square means this m will also get cancelled out. So this will be, I will be left with m. I will be left with m and divided by E b square. So what is pitch? Pitch is the linear distance traveled by these paraxial electrons in one complete revolution, and these paraxial electrons will get refocused after traveling through this distance given by the pitch. So the correct option here is 8 pi square m. The correct option here is B. So in the next session, I will be continuing with the same chapter, that is moving charges and magnetism, but the topic will be different from what we have studied today. So till then, have a nice day. Bye.